This is an example of a real-life scenario where we are going to use right triangles to solve any unknown measurements. I just simply labeled here all unknown measurements. It means we are going to solve for number 1, the distance of ship A to ship Y. Number 2, we could also solve the distance of ship Y to ship Z, the angle here, the angle here, the distance of the tip of ship X to ship Y. We also have this one here. We could also solve this and all other parts that can be solved with accordance to our given figure. In order for us to solve this, let us try to determine first the angles, because the angles will help us later on solve for side measurements, since in this given you only are given with one side measurement, and in a right triangle, and we will assume, by the way, we will assume this to be 90 degrees, so that this is an example really of a real life right triangle. So we are we cannot use here the Pythagorean theorem again if you're only given with one side. Instead, we'll be solving for the unknown measurements of angles so that we could actually solve or use it probably with our SOH-CAH-TOA in solving for the unknown measurements of sides. So let's start with this angle here. Let me use a color blue, this one here. So this angle is an angle formed with the following dimensions: from a tip of X to A, ships X and ship A. We also have this here and this portion here. That's an example of an angle for this triangle. Since we know this to be already 90 degrees and we are given here with 40 degrees, we can say, let's use color blue. Okay, so for the blue angle, this can be solved by subtracting the 2, because this is a triangle, from 180 degrees. So less the measurement of 90 degrees. Okay, and then less 40 degrees here. So we can solve for the measurement of this angle following this process. So let us use this calculator in solving for that. 180 degrees minus 90 degrees minus 40 degrees. We will get an exact measurement of 50 degrees for the blue colored angle. It's exact because all the measurements, this one here and this, are already given. This is 50 degrees. So if I'm going to erase this one here. Okay. This is given to us, or let me use this in here. This blue colored angle earlier, we can label this as 50 degrees. Alright. Next is, how about this angle here? Let me use a red color. This angle here. This is not a part of any 90-degree angle. Or I mean, this is not an angle of any 90-degree triangle or right triangle, because this is the right triangle. The second right triangle that you could have is from A to Z to X. This is just a portion. But this measurement can be solved looking into the perspective of these three angles here. We are going to assume that this is also 90, or that's the right angle, so that this line here is parallel to here. That would mean for the measurement of angle red, we can subtract the two given measurements to get from 90 degrees, so less 40 degrees, less 40 degrees. So we will have an exact measurement. You may or may not use calculator, because that's already exactly 10 degrees. If you would like to and be very sure about that, we will still get 10 degrees. That's for your red colored angle here. So this is 10 degrees. Now, finally, let us solve for this given angle here, which is now an angle of the larger right triangle from X to A to Z. That's a larger 90-degree right triangle rather. To solve for this, we already have 90 degrees here, and the other triangle for the larger angle the other angle for the larger right triangle is this, which comprises 40 degrees, and the red colored angle earlier, which is 10 degrees. So again, the green colored angle is or can be computed by subtracting the 90 degree here from 180 degrees for triangle angle sum theorem, and also subtracting this angle which measures the sum of 40 and 10, which is 50. So minus 50 degrees. So the measurement of the green colored angle, if you would like to be really sure, 180 minus 90 minus 50, but of course you could always predict it to be already 40 degrees. So these are the angles first that we would like to use to complete our given figure. Okay. In connection to the angles, with regards to ship X, let us use and go back to the black colored label. With regards to ship X, there are two distinct angles of elevation. You have this angle of depression rather. This is your first angle of depression. Okay, this is the angle formed by this horizontal line and the line of sight from the tip of battleship X to battleship Z. The other angle that is considered as an angle of depression that can be formed is here. That's the second angle of depression. That's an angle formed by the same horizontal line rather, and the line of sight from ship X to the tip of ship Y. So there are two angles of depression here. As for angles of elevation towards X, you also have two, the green colored angle and the blue colored angle. These two are your angles of elevation. Let me extend it here because we are now going to solve the unknown measurements of sides. Earlier, I made a copy of that, moving it here because we are expecting to have a plenty of scribbles in our first. So we are going to return, just probably copy the given measurements. This is for the angles. This is 50 degrees, which corresponds to your elevation, and the other angle of elevation here to be 40 degrees. So which is the side that we would like to solve? Again, this is 90 degrees. Let us solve the distance from A to Y, meaning this triangle here can be used for that. So we have here this side, and you have two specific angles. It's up to you to which you would be using. Just in this case, I'll be using this angle here, 50. So with regards to angle 50, this is your opposite side. Again, with regards to angle 50. And this is your adjacent side to angle 50. So using SOH-CAH-TOA mnemonic technique. With regards again to angle 50, that's O and adjacent TOA. Because it will be a different perspective if you're going to use the perspective of 40 degrees. It's still TOA, but this is now your opposite and that's your adjacent. So in this case, let's solve the measurement from A to Y. So again, using tangent of 50 degrees is equal to your opposite, which is 3 kilometers over your adjacent side. This is what you're trying to solve. Let's use here a certain any letter, or let's just use, we can't use X. Let's just use here a letter R, because I already used X and Y and A. So R, that's distance from A to Y. So multiplying that, you will have R tangent 50 degrees equal to 3, and divide both sides by tangent 50 degrees. To cancel this out, you'll have here tangent of 50 degrees. So your R is approximately the result of this expression. So you have 3 divided by tangent 50 degrees. So that's approximately 2.52. Okay, 2.52. We are using approximation because we are rounding it off, and the unit should be kilometers. That's for R. We are already done with A to Y. The other measurement that we could solve using angle 50 is this distance from X to Y. So you have X to Y. Let's label this as S so that we can use other letter for that. So with regards to angle 50, I know that some of you will get tempted to use R, which is 2.52 kilometers, approximately 2.52 kilometers. I would like you to use the already given measurement of 3 kilometers. So again, with regards to 50, you will have opposite, and your S being your hypotenuse. Opposite, hypotenuse, sine. So we'll be using here sine 50 degrees is equal to your opposite side of 3 kilometers over your hypotenuse of S. That's not 5, that's S. So fundamental law of proportion, that's S times sine 50 degrees must be equal to 3. Divide both sides by sine, that's sine 50 degrees. You also have here sine 50 degrees. Cancel that out. So your S, which corresponds to your distance from X to Y, is approximately this expression. So you have 3 divided by sine 50 degrees. That's a 3.92, approximately 3.92. So you have 3.92 kilometers. Okay. So we are done with this. Now, you could again think of this. 50 is larger than 40. That's why your R is shorter than your 3 kilometers. And your S, being your hypotenuse for this first triangle, is always the longest. That's 3.92 versus 3 versus 2.52. That's for these two measurements first. Next, let's try to solve this M here. M corresponds to the distance from a tip of X to the tip of Z. In this case, we'll be using the second right triangle here, the larger right triangle. We're going to use this larger triangle here, which still has 90 degrees at this point and uses the same 3 kilometers. But the angle now that is given is this 40 degrees. So we are going to solve, move, okay, additional space here. Okay, so we are going to solve X to Z. X to Z, to which I already labeled as M. So M is the hypotenuse. With regards to the 40-degree angle, this was the reason why earlier we started with angle, so that we could easily solve for sides here. So again, 40 with regards to 40, the 3 kilometer is still your opposite, and this is your hypotenuse. So opposite, hypotenuse, we'll be using sine. But it's not 50 degrees. Don't be confused with that. Sine 40 degrees is equal to 3 kilometers over M. Again, don't be confused with earlier sine 50, 3 over s, 3 over m, because they are now different angle measurements. So you have m times sine 40 degrees equal to 3. Divide by sine, that's sine 40 degrees to cancel this out. So we'll be dividing this by sine, 40 degrees. So m is approximately the result of this expression. You will have 3 divided by sine 40 degrees. That is 4.67, approximately 4.67 kilometers. Okay? You just need to really work on your SOH-CAH-TOA and the proper nomenclature here. Now we still have one more side, and that's actually the measurement of y to z. But let's pause for a while. This side here is a side of a triangle which is not a right triangle. This is the side of this triangle here. 1, 2, 3. So we cannot use here SOH-CAH-TOA because SOH-CAH-TOA is specifically for right triangles. But we can solve or add another method to solve for this. What is that method? Our method is actually going to solve first a to z. We will solve a to z so that this is a side of the larger right triangle. And after that, since we already have the value for r earlier, we will just simply subtract r to the value from a to z. Let's label that as k. Okay. Or let us not use k. Let's use it as p. So once we are done solving for p, subtract r, you will get this value here. So when solving for p, that's actually a to z. That's your p. This is again the side of your larger triangle, but specifically with regards to your given angle measurement of 40 degrees, the green colored angle, side P is your adjacent side. You might use M as what you have solved earlier, but this is not exact. Again, let's use the given 3 kilometers, which is your opposite. So opposite, your P is your adjacent to 40. We will be using TOA. So we will have here tangent of 40, not 50, because that's the angle that we're referring right now. TOA, it's still 3 divided by P. So comparing it from earlier, tangent 50, 3 over R, tangent 40, 3 over P, rather, they're at the same. So cross multiply, you'll have P tangent 40 degrees is equal to 3 divided by tangent 40 degrees. You also need to divide this by tangent 40 degrees. The left hand side will be cancelled out. P is approximately this expression, which is 3 divided by tangent 40 degrees. That's 3.58 rounded off into 2 decimal places. 3.58 kilometers. This is P, but not the value that we are trying to solve earlier. We are going to use another method. Again, this, let's say this is letter T. The value of T is when you will subtract R from P. So again, T, this side is when you have P minus R. These are both approximation, so we are going to use approximation on the final answer later. But just for the moment, that's 3.58 kilometers minus your R of 2.52 kilometers. That means your T is approximately, we are using approximation because both values are already approximated, So you will have 3.58 minus 2.52 kilometers. That's approximately 1.06 kilometers. This is T. We are done with that. R, S, M, P, we use that to get T and all the intended angles as earlier. So we are done solving all the unknown measurements of the given figure. Why are we doing this? Because in future problems, you might be only asked with one side or one angle measurement, but at least for this given video, you were able to solve, or we were able to solve, all unknown measurements.